null hypothesis states that the expected cause has no effect on the outcome. Hypothesis: a rational explanation of a phenomenon that has not been proven. It is the starting point for scientific experimentation and is an empirically testable conjecture. Theory: fact: something that is always true. In science, these are verifiable and are verified by repeated experiments conducted by different researchers who yield the same data. Scientific law: a formal scientific statement that describes a phenomenon that has been scientifically proven to absolutely and invariably occur under given conditions. These are led to be true and universal statements of fact meant to describe phenomena. Models: simplified substitutes that make concepts or processes easier to visualize and understand. Scientific design: a procedure to create a fair test of a hypothesis. A completely fair test is one that shows no bias or favoritism toward any variable, whether controlled or uncontrolled, within the experiment. Experimental design: problem statement: a clear definition of the problem to be investigated. The hypothesis is based on this. Independent variable: the factor being tested and is manipulated by the researcher. Dependent variable: a measurement of the independent variable. Test group: the selected participants in the group that is in keeping with the intent of the independent variable. Control group: a subset of the target group and is used as a comparison to show any changes in the target group that occurred because of the independent variable. Once established, the remainder of the target group becomes the treatment group. Treatment group: the population that will receive the independent variable treatment. Uncontrolled variables: a major source of experimental error and may render the data useless. SI units: how measurements in science are expressed, typically metric. Base units: what SI is built upon. These define the unit absolutely and do not require referencing other units. These are then combined with SI prefixes to make the unit of measure smaller or larger. Precision: refers to how close several measured values are to each other. Accuracy: how close the measured values are to the true or actual value. Charts: refine raw data into an organized format. Graphs: there are many of these used in science. The three most common are line, bar, and pie. Percent error: compares experimental results with a known or expected value. Experimental error: occurs in most student experiments and comprises the concept of a fair test of the hypothesis. Material safety data sheet: on file in a lab. This helps teachers know the proper use, storage, and disposal of chemicals. Inventory: includes a list of chemicals, dates, and amounts for a lab. Solid: has a definite volume and does not need a container to maintain its shape. The structure of these can be either crystalline or amorphous. Crystalline solid: has a regular and repeating arrangement of particles such as atoms, ions, or molecules. The four types include ionic, molecular, network, and metallic. Amorphous solid: has no regular or repeating arrangement of particles, has definite volume, and does not need a container to maintain its shape. Heat of fusion: the amount of energy needed to overcome the intermolecular forces that hold the substance together as a solid. Vapor pressure is exerted by gas molecules when in equilibrium with its liquid phase. Viscosity, the resistance of a liquid to flow. Surface tension, a measure of the resistance of a liquid to spread out. Boyle's law states that for a fixed amount of an ideal gas at a given temperature, the pressure and volume of that gas are inversely related. P1V1 equals P2V2. Charles's law states that for a fixed amount of an ideal gas at a given pressure, the volume of the gas is directly proportional to its absolute temperature. V1 per ton 1 equals V2 per ton 2. Gay-Lussac's law states that for a fixed amount of an ideal gas at a given volume, the pressure of the gas is directly proportional to its absolute temperature. P1 per ton 1 equals P2 per ton 2. Standard molar volume for any 1 mole of any ideal gas at STP is 22.414 Il. Standard temperature and pressure 1 atmospheres and 273 kelvins or 0 degrees Celsius. Nuclear fusion. Within the core of a star, this forms successively larger atoms. Supernovas. The explosions of massive stars. Scientists theorize that elements heavier than iron, such as gold and lead, are formed during these events. Transmutation. The process in which atomic nuclei are changed, which has allowed chemists to create synthetic or man-made elements. Superheavy elements. Those elements with an atomic number greater than 106 and are created in a synchrotron or particle accelerator. Physical change is one that alters the physical state of a substance without changing its composition or forming a new product. No new substances are formed and no chemical bonds are made or broken. Chemical change is one in which a chemical reaction occurs. Chemical reaction. In this, bonds are broken and formed, creating new products that have different chemical properties from the original raw materials or reactants. Law of conservation of mass and energy states that atoms and energy cannot be destroyed in a chemical reaction. Energy, the capacity to do work. Potential energy, stored energy. Kinetic energy, the energy of motion or action. Temperature, the measure of heat in a system. Heat, thermal energy that is moving from a hot to a colder temperature. Thermal energy, the type of energy stored in an object and is a measure of the random kinetic energy of each atom in that object. Specific heat, the amount of heat required to increase the temperature of a unit of mass of a substance 1 degree Celsius. First law of thermodynamics states that energy is interchangeable but cannot be created or destroyed. Hess's law states that the heat requirement for any reaction is constant and independent of the manner in which the reaction takes place. Second law of thermodynamics states that no natural reaction or process can occur unless it is accompanied by an increase in entropy. Entropy is a measure of the randomness of the universe. It also tells how much energy is available to do work. Democritus created the term atom. Atoms. These are the smallest parts of an element that retains the properties of that element. They are made of protons, neutrons, and electrons. Antoine Lavoisier. This person discovered the law of conservation of mass. Law of conservation of mass This states that the mass of the products of a chemical reaction were exactly the same as the starting materials. In other words, no matter is lost during a chemical reaction. Dalton's laws. These state that all matter is made of very small and non-breakable particles called atoms. All atoms of an element are similar and atoms of a different element are different, and atoms are not created or destroyed in a chemical reaction. J. Thomson. He demonstrated that electrons are a part of the atom. They are very small and have a negative charge. He stated that the atomic arrangement was similar to plum pudding. Ernest Rutherford. He determined that the positive charges are contained in a nucleus. He also concluded that most of the atom is empty space and the negatively charged electrons swarmed around the positively charged nucleus. Niels Bohr. He discovered that electrons travel around the nucleus in well-defined energy levels. He stated that electrons that absorb energy move to a higher energy level. Conversely, electrons that give off light energy return to their normal ground state or energy level. James Chadwick. He discovered the neutron, an uncharged particle found in the nucleus of an atom. Electromagnetic force. This holds an electron in orbit around the nucleus. The opposite charges within the positively charged protons and negatively charged electrons draw the electrons toward the nucleus. Electron configuration. Principal quantum. Related to electron configuration, these are numbered 1 through 7 and correspond to the period numbers on the periodic table. Subshells compose the principal energy levels and are noted as S, P, D and F based on the maximum number of electrons they can hold. Orbitals compose subshells and are the most specific location for electrons. Each can hold a maximum of 2 electrons. Atomic size of an atom is dependent on the number of electrons and their proton balance, decreases moving left to right across a period and increases moving down a group. Ionization energy. The energy required to move an electron from a neutral atom increases moving left to right across a period and decreases moving down a group. Chemical reactivities. These are features of atoms in the same group. Electronegativity. This decreases moving downward within a group and increases moving left to right across a period and is a measure of the electron attraction to the nucleus. Electrical charge. On an ion is usually the same for the group number for elements in groups 1 to 3. Elements in group 18 have no charge. Elements in groups 5 to 7 obey the following equation: group number minus 8 equals electrical charge. Radioisotope. An unstable radioactive isotope which spontaneously emits energy in order to form a more stable nucleus. Isotopes. These are atoms of the same element that have a different number of neutrons. Radioactive decay. The process in which an unstable radioactive nucleus or radioisotope emits radiation, thereby forming a more stable nucleus with a different composition. Half-life. The time it takes for 1/2 of the radioactive isotope to decay. Radioactivity. The energy or nuclear radiation emitted from a radioactive isotope. Radiation. The process of emitting radiant energy whereby particles and nuclear energy are released by radioactive isotopes. The 4 types include alpha particle, beta particle, gamma, and positron. Alpha decay. In this type of decay, the nucleus ejects 2 protons and 2 neutrons. The particle is symbolized a helium atom. Alpha particles. High-energy particles that decrease the number of protons and neutrons in the nucleus by 2 each. Beta decay. This occurs when a neutron splits into a proton and an electron, with the proton remaining in the nucleus. Beta particle. A high-energy electron. Gamma decay. This releases gamma rays or high-energy radiation from a radioactive nucleus. Positron. An antiparticle of a beta particle, the charge of which is positive. These are formed when a proton reforms into a neutron. Speed. This is the distance traveled divided by the time it took to travel that distance. The SI unit is meters per second. Scalar. This is a unit that is completely definite by its magnitude, such as mass, speed, or length, and does not contain a direction unit. Vector. A quantity that has magnitude and direction. Velocity. A vector quantity that is determined by speed and direction. Acceleration. The rate at which the velocity of an object changes over time. This will change if speed, direction, or both change. Positive acceleration. An increase in velocity. Negative acceleration. A decrease in velocity. Position. This defines the location and specifies a reference point of an object. Motion. The change in an object's position relative to a fixed reference point. There are 4 types: straight line, projectile, circular, periodic. Straight line motion. Motion in one dimension and is similar to a ray in geometric terms. This is affected by unbalanced forces acting at any angle other than on the ray. Projectile. An object that is influenced by gravity only. It continues in motion because of its own inertia. Projectile motion. The motion of an object that is dropped, shot, thrown, launched, or otherwise thrust into the air. The trajectory of the object is the pathway that it follows, which is directly influenced by gravitational force. This explains the motion of an object moving in 2 dimensions. Circular motion. Motion along a circular pathway or orbit. This is also described as the rotation of an object around a fixed point and typically requires a continual input of energy to keep the object in motion. Uniform. With a constant angular rate of motion. Non-uniform. With a variable angular rate of motion. Periodic motion. Any motion that is repeated in equal time intervals, or a motion that repeats itself in equal regular periods or intervals. This requires a continual input of energy to maintain the equal pattern of movement and time interval. Newton's first law of motion. This is based on Galileo's idea and is often called the law of inertia. It states that an object continues in a state of rest or at uniform speed unless acted upon by an unbalanced force. Mass. The amount of matter an object contains. Weight. A measure of the gravitational force on the mass of an object. Force. A vector with a magnitude and direction and is simply any action on an object that produces a change in its motion. It is a push or a pull and the unit for it is kgm sector the 2, also known as a Newton. Newton. One of these is the amount of force required to accelerate 1 kilogram at 1 meter per second to the 2 at any location in the universe. Newton's second law of motion. This states that the acceleration of an object is equal to the amount of force applied to the object divided by the mass of the object. A equals Fm. F equals. Newton's third law of motion. This states that for every action there is an equal and opposite reaction. Work. A scalar quantity that is defined as the product of force and distance. W equals Fxt. This can also be described as the transfer of energy. The unit for this quantity is the joule. Joule. The amount of work done when a force of 1 N acts over a distance of 1 m, also known as a Newton meter. Energy. This is transferred through the action of work, the property of a system that enables it to do work. It is also thought of as a system's ability to make changes, such as raising temperature, creating new matter, breaking chemical bonds, etc. Chemical energy. This type of energy is stored in molecules such as glucose, which powers your body, and in the form of batteries, which power your toys. Electrical energy. This type of energy is created by other types of energy using means such as chemical, nuclear, or perhaps solar energy to spin an electrical generator. Light or radiant energy. This type of energy includes the spectrum of electromagnetic waves. Examples include sunlight, radio waves, and microwaves. Mechanical energy. This type of energy contained within an object due to its motion or position and can be either potential or kinetic in nature. Power. Watt. This describes the flow of energy from one place to another place, such as the flow of electricity through a wire. One of these is equal to 1 J per second. Horsepower. This is the measure of work being done by force and is based on the average amount of power output performed. One of these equals 746 watts. Machine. This is a device that changes the direction or size, or both, of a force. This makes work easier but does not eliminate or reduce the amount of work being done. Mechanical advantage. A number that tells the amount that a force is multiplied by a machine. It is equal to output force input force. Simple machine. The simplest device that provides a mechanical advantage by changing the direction or magnitude of a force. 6 types include inclined plane, lever, pulley, screw, wedge, wheel and axle. Inclined plane. A slanting surface that connects a lower level to a higher level. Lever. A rigid structure that lifts or moves loads and rests on a fulcrum. First-class levers. These types of levers locate the fulcrum between the input force and the load, and they always change the direction of the input force. Second-class levers. These types of levers locate the fulcrum at one end of the rigid structure and the load before the input force on the other end of the rigid structure. These do not change the direction of the input force, but do allow less force to be exerted than that exerted by the load. Third-class levers. These types of levers locate the fulcrum at one end of the rigid structure and the input force before the load or output force on the other end. These do not change the direction or increase the input force, so the output force is always less than the input force. Pulley. An axle through a grooved wheel around which a cord, rope, or cable is used to raise or lower objects. Fixed pulley. A single pulley that is attached to an unmovable object. This type of pulley has a mechanical advantage of 1 because the distance of input and output force are the same. Pulling down on the rope lifts the load on the other end of the pulley the same distance. Movable pulley. A pulley that has a mechanical advantage of 2 because the pulley moves up as load is lifted. This pulley is attached to the load. These do not change force or direction, but do increase force by increasing the distance that the input force is exerted. Block and tackle pulley. A combination of fixed and movable pulleys. The MA is equal to the number of rope segments in use. This also means that the rope has to be pulled that distance. One with 6 rope segments has a mechanical advantage of 6, but the rope must also be pulled 6 m to lift a load 1 m. Screw. An inclined plane wrapped around a central vertical line or cylinder. This essentially turns rotating motion into linear motion. Wedge. An inclined plane or pair of inclined planes that can be moved to separate 2 substances. Wheel and axle. Torque. This is a measure of how much a force acting on an object causes the object to rotate. It is not a force but is created by a force and is the rotational equivalent of force. Torque arm, lever arm. The perpendicular distance between the line of action of the force and the center of rotation. Center of rotation. This is the point or line around which an object rotates. Momentum. This is a vector quantity that occurs as a product of the object's mass and its velocity. This is a property of matter in motion. This is the tendency of objects to keep moving in the same direction with the same speed. Impulse. A measure of the product of the magnitude and duration of the collision force. Impulse-momentum relationship. This states that an impulse is equal to a change in momentum. Inertia. A body's resistance to a change in motion. Law of conservation of momentum. This states that the total amount of momentum in a system cannot change. This assumes no outside forces or interference, such as friction. Linear momentum. The momentum that occurs when an object is in linear motion, which is straight line motion and results from an object moving in a straight line. Angular momentum. This describes the rotation of an object. Elastic collision. This is where objects do not stick to each other but bounce off each other with no loss in the total amount of kinetic energy. Inelastic collision. Colliding objects stick together and some of the kinetic energy is lost as heat, friction, sound, and change of shape. Moment of inertia. The sum of the mass times the square of the radius for all of the particles in a solid object. Gravity. The force of attraction that gives weight to objects with mass and causes those objects to fall when dropped to Earth. Law of universal gravitation. States that all objects in the universe attract each other because of their gravitational force. Force equals G. Gravitational attraction. This exists between two objects and is dependent on their masses and their distance from each other. Free fall. This occurs when no outside forces are acting on an object other than gravity. Terminal velocity. This is the velocity at which the air resistance and gravity are equal, so the object continues to fall but the acceleration is zero. Pascal's principle. Hydraulic. These devices are based on Pascal's principle and can multiply forces. They are commonly used when a small force is needed to move a big object. Buoyancy. An upward force that is exerted by a fluid which counteracts the weight of an object immersed in that fluid. Buoyant force. The upward force that fluids exert on all matter. Archimedes' principle. This states that an object immersed in a fluid is buoyed up by a force equal to the weight of the fluid it dispenses. Bernoulli's principle. This states that when the speed of a fluid increases, the internal pressure of the fluid decreases. Streamlines. Thin lines that represent the smooth flow of a fluid. Electric forces. These are created by atomic particles. Electrical charge. A fundamental physical property of matter which can be either positive or negative. Coulomb. Of electrical charge is equal to the charge of 6.25 e-18 protons or electrons. Law of electric charges. This law states that like charges repel and unlike charges attract. Electric field. This created by an electric force in the area around charged objects. Electric power. The rate at which the moving charges or electricity convert electric energy into another form of energy, such as heat or light. It is measured as the product of current and voltage. Watt. The unit for power. Ampere. Unit for current. Electric current. This is the flow of loose electrons, electric charge, or electricity in an electric circuit. It is also the rate at which electric charges pass a given point in a given amount of time. In other words, it is the number of electrons that move past a given point in 1 second. Electric potential. The potential energy per unit of charge at a specified location. Electric potential difference. The difference in electric potential between two given locations. Volt. The unit for electric potential difference and is equal to 1 joule per coulomb. Voltmeter. How volts are measured. Voltage. Electric potential difference which draws the current from a high potential area to a low potential area. Conduction electrons. Free electrons in a wire which are responsible for the conduction of the electric current. Insulators. These prevent the flow of electric current. The most efficient ones do not contain conduction electrons. Semiconductors. A hybrid between good conductors and good insulators. These have fewer conduction electrons than good conductors but have more conduction electrons than insulators. Superconductors. Materials that have zero electrical resistance to the flow of charge. Types of electric current. Direct current and alternating current. Direct current. The charges always flow in the same direction, positive to negative. Electrons are repelled from the negative terminal and attracted to the positive terminal within the circuit. Alternating current. The charges continually alternate or reverse directions. Hertz. The unit for measuring AC current. 1 is 1 cycle per second. Capacitor. A device that stores an electric charge. It serves as a reservoir of electric charge and is often used for a quick burst of charge. Capacitance. The ability of a capacitor to store a charge which is measured in farads. It is the ratio of the charge to the potential. Circuit. Any pathway that allows electrons to flow. There are two types, series and parallel. Series. This type of circuit provides only one pathway for electron flow. Parallel. This type of circuit contains branches, providing more than one path for current to flow through. Resistance. The opposition to the flow of electric current by a device such as a light or material such as a wire. It is measured in ohms. Total resistance. The sum of all individual resistances within the series circuit. Ohm's law. This states that current equals voltage divided by the total resistance, I equals VR. Voltage drops. These are the sum of each individual resistance in a series circuit. Kirchhoff's voltage law. This states that the sum of all voltage drops must equal the total voltage provided by the source. Circuit breakers. These safety fuses are connected in series along a circuit and are designed to break the circuit whenever a wire is overloaded, thus possibly preventing a fire. Electromotive force. Voltage generated by a battery. It represents energy per unit charge or voltage which is created by a generating mechanism like a battery. Gauss meter. This is used to measure an amp strength. Magnets. These have the ability to exert attractive and repulsive forces on magnetic materials. Magnetic field. An energized area around a magnet where magnetic forces have an influence. Solenoid. a conduction coil of wire that, when carrying current, produces a magnetic field. Electromagnet. This is created by a solenoid wrapped around a magnet. Transformers. These are devices that use the induction of electricity to increase or decrease the voltage of alternating current. Step-up transformer. This is wired so that the primary coil has fewer loops than the secondary coil, so the voltage in the secondary coil is higher than the primary coil. Step-down transformer. This is wired so that the primary coil has more loops than the secondary coil, so the voltage in the secondary coil is lower than the primary coil. Galvanometer. This detects electric current. Ammeters. These are galvanometers that are calibrated to measure electric current or amperes. Voltmeters. These are galvanometers that are calibrated to measure electric potential or volts. Wave. An oscillation that travels and moves energy from one place to another. Wavelength. If a wave is the distance between neighboring crests or troughs, the distance between two equivalent parts of adjoining waves. Period. Of a wave, the time it takes for a complete vibration or cycle. Frequency. The measure of how often a wave oscillates at any given point. It is defined as the number of waves in a given unit of time and is measured in hertz. Amplitude. The maximum distance of oscillation from the resting point, midpoint, or equilibrium level of a wave to its peak or trough. Wave speed. A measure of how fast a wave travels or how fast the wave can transmit an oscillation to a different location. It is equal to wavelength x frequency. Transverse waves. These oscillate the particles of a medium in a direction that is perpendicular to the direction of motion of the wave. Longitudinal wave. This is identified as a wave that has oscillations in the same direction as the wave is traveling. Compression and rarefaction are characteristics of these type of waves. Compression. An area where particles are crowded together, such as the gathering of the coils. Rarefaction. An area where particles are spread apart. Surface wave. This looks like a transverse wave, but the medium is moving in circles as opposed to up and down. Reflection. The change in wave direction as a wave bounces off a barrier. Echo. A reflected wave. Law of reflection. The angle of incidence is equal to the angle of reflection. Refraction. This occurs when waves move through a boundary from one medium into another medium, causing the waves to bend. Diffraction. A change in wave direction as the waves pass through an opening or curve around a barrier. The waves bend. Absorption. This occurs when waves pass through objects. The amplitude of a wave decreases as it passes through a medium. Superposition principle. This states that the sum of the oscillations for all waves within an area creates the total oscillation for that given area. Constructive interference occurs when the crests and troughs of two or more transverse waves overlap. Destructive interference occurs when the trough of one transverse wave overlaps the crest of another wave. The resulting wave has less energy and smaller amplitude than either of the original waves. Doppler effect. Redshift. The appearance of spectral line identification patterns that are at a longer wavelength. This is an indicator to astronomers that the galaxies are moving away from each other because the waves are longer than expected, meaning the universe is still expanding. Blue shift. This would indicate that the waves are compressed and the galaxies would be coming together, indicating the universe is contracting. Polarization. This occurs when transverse waves oscillate or vibrate in the same plane as the wave. Plane polarized. This means that the waves traveling along a spring, for example, are limited to travel in that plane only. Sound waves. These waves require a medium to travel because the longitudinal wave has to be compressed and stretched to transmit energy. Sound. This is produced when an energy source causes the air molecules or other media to oscillate or vibrate. The vibrations are made of compressions and rarefactions that spread from the energy source as a sound wave. Pitch. The highness or lowness of sound that is determined by wave frequency. Loudness of a sound. This is determined by its wave frequency. Decibels. What loudness is measured in. Speed of sound. This is 600 miles per hour or 343 meters per second measured at 1 atmospheres and 21 degrees Celsius. It is influenced by a number of factors such as pressure and temperature, both of which increase speed as they increase. Electromagnetic spectrum. A continuous range of electromagnetic waves which includes the least energetic radio waves through the most energetic gamma rays. Visible light. Light that can be seen by humans, one of the narrowest parts of the EMs. White light. A product of all of the colors with invisible light mixed. Plane mirror. Flat mirror. Real image. This is formed when many light rays from the same point on an object converge together. Virtual image. Formed when many light rays from the same point on an object do not converge. Concave mirrors. These contain an inward curve that concentrates the light rays at a single point, thereby presenting as a different image than that of a plane mirror. The image reflected is determined by optical axis, focal point, and focal length. Optical axis. This is a straight line drawn from the center of the mirror to the object. Light rays traveling along this are not bent by any type of mirror or lens. Focal point. This is the single point where light waves parallel to the optical axis are reflected. The bent light rays converge. Focal length of a mirror is the distance between the surface of the mirror and the focal point. Of a lens is the distance between the center of the lens and the focal point. Convex mirrors. These contain an outward curve that always creates a virtual image that is smaller, upright, and closer to the mirror than the original object. Lens. This is a transparent object that has a curved surface that creates an index of refraction different from air. These are able to refract or bend light, and their shape determines how the light rays are bent. Converging lens is thicker in the middle than around the edges and are designed to bend an incident or incoming light ray to a single focal point. Virtual image is larger than original. Divergent lens is thinner in the middle than around the edges. Virtual image is smaller than original. Nucleus comprised of neutrons and protons. Atomic number identifies atoms by representing the number of protons in an atom. Mass number represents the number of protons added to the number of neutrons in an atom. Periodicity, a phenomenon where chemical and physical properties of atoms occur in regular and predictable ways. Periodic table of elements. This demonstrates the periodicity that exists within the known elements, an organized listing of both natural and man-made elements. Electron affinity. This measures the ability of an atom to receive an electron. Mole. The amount of a substance that contains as many atoms, molecules, ions, or other chemical units as the number of atoms in 12 grams of the isotope carbon-12. Avogadro's number The number of particles defined in a mole equal to 6.02 x 1023. Chemical bonding occurs when two or more atoms combine to create a new substance. Ionic compounds for when a metal donates valence electron to a non-metal. Covalent bonds occur when valence electrons are shared between the atoms of nonmetals or between nonmetals and metallites. Polar covalent molecules. These are formed when a covalent bond between two or more atoms has ionic characteristics. Electron dot structure. In these, the element is identified by its symbol and the valence electrons are represented by dots around the symbol and observing the rules of electron pairing. Lewis structures. Electron dot structures for molecules. Chemical formula. A symbolic representation of the compound or molecule that is formed as a result of a chemical reaction. It includes the symbol for each element within the new product along with the ration of each element. Hydrocarbons. Organic molecules in which the carbon chains are only bonded to hydrogen atoms. Alkanes. A type of hydrocarbon in which all carbon-carbon bonds are single bonds. Alkanes have at least one carbon-carbon double bond. Cycloalkenes